Welcome, Form 4, Physics, Topic 5, Waves, Notes, Lesson 5. You must have watched Lesson 1 until 4 before this. We continue with the vibrations of a loaded spring. So we have a spring whereby at one end is fixed to a point, and the other end we have a load of mass m. We have a load of mass m. Now this spring has something called the spring constant. Spring constant, symbol K, is a property of a spring. We will learn spring constant in Form 5, Form 5, Topic 1. Now this load, it will undergo vibration. How? It will go up and then come down, go down again and then come back to the same place. Which means basically this load will undergo vibration, go up and down. Anything that is vibration, of course, must have frequency. We already learned in the previous lesson that frequency is the number of oscillation per unit time. Frequency, number of oscillation per unit time, meaning 1 second, 1 second. And for the loaded spring, the formula is F equals 1 over 2 pi square root K over M, whereby K, as usual, is the spring constant and M is the mass of the load. Now, on previous lesson, we have learned that the frequency is equals to 1 over period T. Frequency is 1 over T, period. So, from the formula of frequency, if I invert or inverse, I can get the formula of period, which is 2 pi. So 1 over 2 pi has become 2 pi. The square root maintained. K over M now becomes M over K. So period is 2 pi square root M over K. Previous lesson, that the period is time. It is time for one oscillation. Okay, period is time for one oscillation. Previous lesson. Next, now we look at what are the factors of frequency F. What are the factors for frequency F? Meaning, what are the things that is going to affect the frequency? Now, to find the factors of frequency, we will use the formula of frequency. To find factors of frequency, use the formula of frequency that we learned just now. That the F equals to 1 over 2 pi square root K over M. Now, from this formula of frequency, we are going to get the factors of frequency. Now, before that, I do some revision. In any formula in physics, example, A equals to B over C. A, B, C are physical quantities. Now, in any formula such as A equals B over C, up and up is directly proportional. Up and down is inversely proportional. Now, what is the meaning of A and B directly proportional? It means if A increase, B increase. A decrease, B decrease. And A and C inversely proportional means that the A inversely proportional to C. It means when A increase, C decrease. And when A decrease, C increase, the opposite. So that means from this formula frequency, the F and the K is up and up. F square root K up and up directly proportional. That means the frequency of the loaded spring is directly proportional to the square root of K. And another factor, F and M is up and down, inversely proportional. So now the frequency inversely proportional. One is inversely, you have to write 1 over. Inversely write 1 over. So the frequency is inversely proportional to the square root of M. F frequency inversely proportional to the square root of M. So we have two factors that is affecting frequency. One is square root K, which is directly proportional. One is square root M, which is inversely proportional. But there are other factors of frequency. You see, based on Form 5, Topic 1, in the subtopic of Hooke's law, this is Form 5, we also can get the factors of K. You see, frequency directly proportional to square root K. There are factors that affect K also from Form 5. Now from this Form 5, quite a lot, you watch. This is from Form 5. The K directly proportional to the thickness of the spring wire. I will explain afterwards what is thickness. But the K directly proportional to the thickness of the spring wire, inversely proportional to the diameter of spring, and also inversely proportional to the length of the spring. This diameter of the spring wire, diameter of spring, length of spring, I'm going to explain in a short while. And this K is also directly proportional to the stiffness. Stiffness means kekerasan. And inversely proportional to elasticity. We will learn elasticity in Form 5. For time being, just memorize. Now coming here, I've drawn a spring. Okay, this is the diameter of the spring. Diameter of the spring, this thing. Diameter of the circle. And this is the length of the spring. Length of the spring. Whereby, if this spring, if I would wire, I draw it big. The wire here, I make the drawing big like this. This is the wire of the spring. So this is the thickness of the spring wire. Okay, this one is the thickness of the spring. Also sometimes they call the diameter of the wire. So we have two diameters. Diameter of the wire and diameter of the spring. Okay. Next. So far we learned, what we have learned is the factors of K. Sorry, the factors of frequency. We only learned the factors of frequency. How about the factors of period? You see, the factors of frequency is the opposite of the factors of period. Example, if frequency is proportional to a factor A can be any factor, the period must be inverse to the A is any factor. And if the frequency is inverse to a factor B, then period will be proportional, which means the F and T is exactly the opposite. Why is it opposite? Because frequency is inverse to period. So any factor proportional to frequency, it must be inverse to period. Okay, similar to this. Thank you. I see you on the next.